Hi guys, I was getting some questions about rational exponents and the activity that I asked you guys to do today. So I just wanted to make a quick video explaining rational exponents, what they are, and how to evaluate them. So, first of all, you guys should remember from earlier in the year that a rational number is any number that can be represented as a fraction, right? Sometimes you hear people say that it's any decimal value that terminates or repeats, which is true because every fraction will come out either as a whole number or as a decimal value that eventually terminates or repeats, right? So some examples of rational numbers could be any whole number, right? So like 1, 2, 3, 4, and so on. Or any fraction like 1/2, 2/3, 3/8. These are all rational numbers. So when you see these numbers in the exponent slot of certain expressions, this is what I'm referring to when I talk about a rational exponent. So how can I evaluate rational exponents? Let's touch on that because that is what I was asking you guys to do today. So, I can scroll up and down. Discovery. Look at that. Ain't that something? Okay. Sorry. So let's see how to evaluate rational exponents. So let's say I have x to the a over b power. Okay? And let's say I wanted to get a value for this expression, which is what I was asking you guys to do today in the schoolwork. So to convert this into radical form, converting this into radical form is always going to be how you're going to be able to get values for these. Although, if you have a graphing calculator at home, you can plug in a rational exponent and you will get an answer. But to make life easy for you, in order to convert this into radical form, right, the x, the base, is always going to go underneath the radical sign still. And let's do this in colors. The denominator of the fraction of the rational exponent is always what's called the index of the radical. So it's the root you're looking for. You might be looking for a square root or a cubed root or a fourth root. In other words, you're looking for a number that multiplies by itself this many times to give you the number underneath. And the second number, the numerator of that fraction, let's do that guy in green. This guy is going to come over here, and he is going to be the exponent on the inside of the radical sign, right? So let's look at a quick example, and I'll go back to my regular blue color here. If I had, let's say, 8 to the 1/3 power, in radical form, what that would look like is the cubed root of 8 to the first power. Okay, I just took this rational exponent and I converted this guy into radical form. And now this is easy for me to evaluate. I can evaluate this one in my head, right? If I'm looking for the cubed root of 8, what I'm looking for is a number that I can multiply by itself 3 times, that's what this guy tells me, to get 8, which is the number underneath, right? So I know that 2 times 2 times 2 is equal to 8. So I know that the third root of 8 is equal to 2. And equivalently, I know that 8 to the 1/3 power is equal to 2. Okay? So let's take a look at some of the questions from today's work. So somebody asked me, is it okay that some of these are coming out as decimals? And it's totally okay. No big deal. That's supposed to happen, right? So I'm going to pick one off your worksheet. So I see 6 to the 3/2 power. Okay? So let's look at this guy. First, let me convert it to radical form. Okay? I'm going to convert this to radical form by making it the square root of 6 to the third. Side note, if the index of the radical is 2, generally we do not write it. It is implied when you just see the square root symbol that the index is 2. So I don't actually have to write a little 2 in there. You're not going to see in textbooks or in other math classes, you're not going to see them writing this here unless it's a number bigger than 2. Okay? Now, as far as evaluating this guy goes, all you have to do here is take the square root of 6 to the third power. So in my calculator, I'm going to throw in 6 times 6 times 6. Whoops, I messed it up. And I get 216. So the square root of 216 is equal to 14.69693. How about we just round this to 14.7 and call it a day, right? So what some people might be wondering now is, can I take this square root of 6 and then raise that to the third power? Well, why don't you follow along with me in your calculator and try it? So I'm going to take the square root of 6, and then I am going to cube it, and guess what? I get 14.7. So it actually doesn't matter what order you want to apply these guys in. You can take the square root first and then cube it, or you can cube it first and then take the square root. Either way, you're going to come out with the same answer. Let's try another one real quick before I log off. Alright, so I see 7. Let's go to a new page. I see 7 to the 4/3 power. So follow along with me here. Actually, let's color code this to make it really pop. So I'm going to get rid of that. I'm going to get rid of that. I'm going to put the 4 here. I'm going to put the 3 here. And so the base, this guy, is always going to be what's inside the radical sign. So I have 7. I'm going to put the index of the radical right here. I got that from there. And I am going to take the numerator, and I'm going to make it the new exponent. And so instead of saying 7 to the 4/3 power, what I'm really saying is the cubed root of 7 to the 4th. So let's just evaluate this together, and give me a second here because I'm doing this on my iPhone calculator because my real calculator ran out of batteries and I can't seem to get AAA batteries anymore. So I am taking the cubed root of 7, which I'm seeing come out as 1.913. I'll round it to. And now I got to raise that to the 4th power. So again, give me a quick sec here, raising that to the 4th power. And it looks to me like it comes out as 13.391. Again, I'm not really going to beat you up on the rounding. You can really round it however you want. As long as you get it close, I'll know what you're talking about. So what did I do for this one? I cubed rooted it first, and then I raised it to the 4th power. How about I raise it to the 4th power first, and then take the cube root, and we'll see what happens. So what did I have? I had the cubed root of 7 to the 4th power. This time, I'll raise it to the 4th power first. How about that? So 7 to the 4th power is equal to 2,401. And now I am going to take the cubed root of that, which again means I'm looking for a number that multiplies by itself 3 times to give me 2,401. So I take the cubed root, and I have 13.391 again, which is exactly the same as what I had before. And this actually looks like an irrational number, so it's not going to come out perfect when I multiply it back together, right? Because I rounded, but 13.391 times 13.391. This is just me checking it, guys, right? So if I multiply this thing back together 3 times, I should get 2,401. Now, I've written too big, so hang with me one last time. We're almost done. Let's erase these dots. Awesome. Alright, so let's call this, let's take it out a couple more decimal places just so we get a better answer. 13.3905 times 13.3905. I'm getting these numbers from my calculator. 13.390. Squeeze in there, buddy. You guys know what I'm talking about, though. 3905. Okay, very good. Now I'm going to multiply these guys back together on my calculator. You guys can follow along with me. 13.3905 times 13.3905 times 13.3905 equals 2,400.99. Again, like I said, it's going to be a little off because we rounded earlier, but this is pretty darn close to my 2,401 that I started with. Alright? So I hope this helps you guys today. If it doesn't help you, just comment on this post. I'll make another video. I'll do some more examples. Whatever I gotta do, I'll do it.